Please open to page 247 in your student journal. What we're going to be working on in Chapter 8 is graphing quadratic functions. So let's just refresh on what a quadratic function is. A quadratic function is a function, aka an equation, where the highest exponent on the variable is a 2. So here is what is known as the parent quadratic function, and we have f of x equals x squared. Remember that f of x, that's just function notation. If that bothers you, you can rewrite that as y equals. Anytime you see the f of x or any variable with the x, you can rewrite that as y equals. Parent function, all that means is it's the most basic, simplest form of that function. The graph of a quadratic function, we see the graph of y equals x squared below. The graph is called a parabola. Parabola is kind of a U-shaped graph. It could open up, like you see below, or it could open down, like this. Two of the important features on the parabola are the vertex and axis of symmetry. The vertex for a parabola that opens up is the lowest point on the graph. For a parabola that opens down, it's the highest point on the graph. Some people also like to call it the middle point on the graph. The coordinates for the vertex for this particular parabola would be 0, 0. The other feature of the parabola is called the axis of symmetry. The axis of symmetry is always a vertical line that divides our parabola into two symmetric parts. So it cuts our parabola in half, it goes through the vertex, and if we fold the parabola in half on the axis of symmetry, the two sides will match up perfect. What I would like you to do now is turn to page 248 and try question number 1 and question number 2. All I would like you to do is identify the vertex and the axis of symmetry for each question. In question number 1, the vertex is going to be the lowest point on the graph. The coordinates will be -1, 1. The axis of symmetry is going to split our parabola in half. It's going to always go through the vertex and always be a vertical line. Since it's a vertical line, we have to make sure that we write the equation of the line. An equation means we need an equal sign. The equation for a vertical line is always x equals, and then we have to figure out what does x equal along that whole vertical line. X equals at any point on this vertical line -1. Notice it's the same as the x value in the vertex. Let's take a look at number 2. Our parabola opens down, so our vertex is our highest point. The coordinates for that vertex will be at 3, 4. The axis of symmetry, again, it's a vertical line. So since it's a line, we have to have an equation to represent that line. The equation of a vertical line is always x equals, and along that whole vertical line, x equals 3. Notice it's the same value as the vertex. So don't get too frustrated with saying, Miss Golly, I didn't have that x equals part. I wasn't sure how to write that. Now we've seen 2 of them. Vertical line has to have an equation. So now that we've seen the basics of a parabola, let's go ahead and turn to page 245 in your student journal. And let's take a look at how we might graph some of these quadratic functions, some of these parabolas. On the graph for letter A is already our graph of y equals x squared. That's already graphed there for us. Now what we want to see is what happens when we multiply the x squared by 3. How does that change our parabola? How does it change our graph? The easiest way to graph these is if we make a little XY chart. And let's try out from, let's do -1, 0, and 1. Let's try that. In the left column, we have all the values that we're going to put in for x. So if my x is -1, I'm going to do 3 times -1 squared. Here's where we have to be careful. In your calculator, you have to make sure you put parentheses around the -1 when you square it. Otherwise, your calculator might tell you that -1 squared is still -1. If you square a number, the result should be positive. So -1 squared should be 1. We do our exponent first, and then we multiply. If we put 0 in for x, we do the exponent first, so we end up with 3 times 0 equals 0. And then let's put 1 in for our x. 1 squared is 1. Remember, exponents before you multiply, order of operations. So now we have 3 ordered pairs. And those 3 ordered pairs should give us a pretty good idea of the shape of our parabola. So -1, 3, -1 on the x, 3 up on the y-axis, 0, 0, and then we have 1 and +3. Let's go ahead and connect our points. Remember, our parabola should be that U shape, nice and curvy. And let's take a look at some of the things that we're seeing here. Our vertex point is going to be our lowest point. It's at 0, 0. So here's our vertex, and it's at 0, 0. Axis of symmetry goes right through the vertex. It's a vertical line, so we have to have an equation, x equals, and along that whole vertical line, the x value is 0. Again, same value as the x from our vertex. Also, take a look at your table. Here's my vertex, and notice the y values are the same on either side of it. Remember, our graph is symmetric. So once you know one side of the graph, here's the point -1, 3, there's going to be a point on the other side that mirrors it. The graph is symmetric. So let's take a look at what happened by multiplying x squared by the 3. Our graph got skinnier. When your graph gets skinnier like that, that is called a vertical stretch. That's the transformation that happened when we had our original graph of x squared and then we multiplied it by 3. It made our graph increase faster, which makes it look skinnier. Let's take a look at letter B. Let's set up a little table. And if you notice, we now have a negative sign. We're multiplying by a negative number, and there's our x squared. Let's set up our x values. And now we have to substitute in for x to get our values for y. Order of operations, we have to be very careful. We have to do exponents first. So -1 squared is 1. We have to square 0 first. 0 squared is 0. 1 squared is 1, and we get negative 5. Negative 1, we have to be careful. The scale on this graph is going by 2's on the y-axis, so be careful when you graph. Positive 1, 5. So multiplying by the 5, it made our graph skinnier. It's our vertical stretch again. There's our 5, made our graph skinnier. But now our graph flipped upside down. The negative sign caused our graph to reflect. The negative sign causes our graph to reflect, which causes it to go from opening up to opening down. Or in other words, it flips upside down. So multiplying by 3 caused a vertical stretch, which means our graph got skinnier. Multiplying by the 5 caused a vertical stretch, which made our graph skinnier. Multiplying by the negative caused our graph to reflect, which made it flip upside down. The vertex point in this case now is the highest point on the graph. Coordinates are 0, 0. Axis of symmetry again splits our graph in half. It's a vertical line, so we have to have the x equals, and along that whole line x equals 0. Again, it's the same as the x coordinate on your vertex. Just want to take a look at one more of these graphs. Let's take a look at letter D. In A and B, we multiplied by numbers that were larger than 1. We had a 3 and we had a 5. Now let's take a look at what happens if we multiply by a fraction. We can set up our same table. And if you just want to enter these things into your calculator, you don't want to write them all out, that's okay. Just want to make sure we're okay with the order of operations. Now, some of you might be a little bit concerned because you're thinking, Miss Golly, how do I graph a fraction when it's part of my ordered pair? If we go over negative 1, 1/10 means I'm going to go up 1/10 of a box. This is not a slope. It's just your y-coordinate for your ordered pair. So we go negative 1, and then we just go up a little bit for the tenth of the box. There's my 0, 0. There's my 1/10. Now you might be thinking, Miss Golly, that's not going to give us a very good picture of our graph. So when you have a fraction you're multiplying by, you might want to do some bigger numbers for your x value, and that's okay. Maybe we go and try, let's try 5. Let's try 5, and then negative 5 should be the same. Let's do 1/10 times 5 squared. So we'd have 1/10 times 25. So we'd end up with 2.5. 1, 2, 3, 4, 5, 1, 2, and then half of a box. Negative 5 is the mirror image of the positive 5. So negative 5 should also be up 2.5. Now when you draw on the curve for your parabola, look at how wide it gets. When you multiply by a number that's smaller than 1, it makes your graph go up a lot slower, which makes it look a lot wider. When that happens, we call it, you could say a vertical, your book calls it a shrink. I call it a vertical compression. I'll leave it up to you which you would like to use. It does not matter to me. So now that we've done these three examples, we've seen a vertical stretch, a vertical reflection, and now a vertical shrink or compression. Let's go ahead and turn to page 249 in your student journal. And we're not going to graph all of these. What I would like you to do for me is just identify the transformation. And by that I mean, is your graph going to have a vertical stretch, a vertical reflection, or a vertical shrink, or again, if you want to use the word compression, if you've already learned that before, you can stick with compression. So let's take a look. Number 3, there's our x squared, there's our parent function. It's being multiplied by 5. 5 is larger than 1, so we're going to have a vertical stretch. In number 4, we're multiplying by -4. The negative sign causes us to have a vertical reflection. The negative sign causes our graph to flip upside down, to open down instead of up. The 4 is bigger than 1, so we have a vertical stretch. The negative multiplying by negative can be tricky because it causes two different transformations. Not only does the 4 cause the stretch, but then the negative sign causes the reflection. In number 5, all we have is a negative sign, so we just have a vertical reflection. Number 6, there's our negative sign to cause our reflection. And then 7 is bigger than 1, so vertical stretch. In number 7, we do have a negative sign, so we have a vertical reflection. And then we're multiplying by 1/5. 1/5 is smaller than 1, so we're going to have a vertical shrink. Or again, if you want to say vertical compression, you may. Last but not least, number 8. I'm multiplying by a number that's smaller than 1, so we're going to have a vertical shrink. Or if you'd rather use the word compression, you may. Either one is okay with me. So if you're multiplying, let's do a little summary. If you multiply by, a number bigger than 1, that's our vertical stretch. A number smaller than 1, that's our vertical shrink. Or again, compression is fine. I know some of you have learned these transformations before. And then if you multiply by a negative number, that's our vertical reflection. As you move on to now do your progress check, You may use your notes to complete that progress check.